Hello students, welcome to EduCell. This video is all about problem solving video where we are going to discuss about union finding operation. There are three operations which we have already studied in disjoint set, where make set functions, find set functions and union functions. We will be working on it. Now let us start with the problem, like what are they set and why we are using it and what are the operations that how we can use it. Those are disjoint set. This part, before going to the video, I must say, those who are new, kindly go for reading this Coreman book. I have collected informations from two different books, which is written by Klenbergs and Tados. Okay, and another book is written by the Coreman with other co-authors. The name of the books are Introduction to Algorithm and Algorithm Design. There are two books I am following for each video. Whenever I am reading the content well, then I go for the videos. And I request all those who are watching this video kindly read from the book, because book is 100% correct thing is written from the book. We people are reading and we try to understand what we understood. That part is based on the video. As a request for all, again, kindly read the book first. Okay, let us start with this video. So here we perform three disjoint set operations, because a disjoint set and joint set is if there are no such connections or edges in between two different tree. Because we know graph and tree, the basic difference is graph there is a cycle could be existing, but in tree no such cycle could be expected. So basic difference here, you can say in A, there are two different graph, you can say, or tree. Okay, so here if I consider two different graph or a subgraph or a subtree here for a graph, so here they both are not having any single edge. If I connect with D, I can say it's a graph, a connected graph here, though no connections between three edges, three different vertices with the four different vertices. We can say this A, which is a graph, we can say is a disjoint graph. So from a disjoint graph, what we are doing the operations are like make set operations, find set operation, then union operation. Okay, so first of all we should know make set operation simply creates a tree with just one node. Like whenever we are using make set operation, for each nodes we are running for one time, because we are keeping one node. First of all, from a graph we keep all the vertices are the independent vertices. To run that one, we have to use the make set operation. Next, for find set operations, we have to check whether both are connected or not to find it. Okay, from a set, basically it's a set operations. From there we have to find whether the element exists or not. If not, then we can go for going for the union. In Kruskal case, like whenever we are finding the MSTs, minimum spanning tree, that time whenever we are using it, the algorithm also I kept here in the next slide. But before that, I'm just giving you such idea. Like in a detailed video, it is clearly mentioned how find set is working. Like it has to find like whether the set, whether the element is there inside or not. So based on that, we will go for the union. Union means, in a mathematical operation, we know we are adding the elements. In a set theory, we have read it properly. Union, okay. So these things we are going to add. Next, you this part we have already discussed in the detailed video. Those who are new, kindly check the detailed video lecture there. So MST, whenever we find the MST Kruskal, G stands for the graph and W stands for the weight here. But this is not our theme to discuss. Our main theme is the make set and find set and union, how it is working. Okay. So to give a proper example, I can say I will take example of a graph where there are might be four edges with the four different vertices. It's a small example I'm taking. So here you can say these are the edges. The weight of the edges has been assigned, because without weight we cannot pick increasing order or decreasing order. We cannot do that one. It's well described in a detailed video. So make set, whenever we are doing a make set, it is written within the for loop. Kindly see it here, where it is written like the vertices represented with a small v, with a g dot v means the number of vertices. The for loop will run how many times you are in this graph. If I'm saying it's a question for us, like how many find set, how many union set, and how many sorry, find operation, union operation, and make operation will be used. If the question will be there, in this case, for loop means for loop will run for the number of vertices. The number of vertices are a, b, c, d, which are four vertices. So make set will run for four times. Here you can say whenever we are running for the make set on small v means the vertices, it will run for four times, because the number of vertices, based on the number of vertices, okay, based on the number of vertices, okay, it is written there. So that is why I'm saying based on the number of vertices it will run. So whenever we are running it, this is just a disjoint graph for us. Yes, for each like for each vertex we are running the make set. Once it is done, now the main strategy is we have to focus on a. Okay, before that find u and uv, before that this uv, the edges, we have to take non-decreasing order, means increasing order. First of all we have to do that. For increasing order you can say here make set is over. I'm just discussing now for the find set. Okay, so for find set the edges will be increasing order. Okay, increasing order, edge. So in increasing order means AC have the weight is 1. Based on the weight actually we are doing the increasing and decreasing. Next, whether I can write in this format A, B. Though it is undirected, you can write B with A. If directed, so U must be first, V must be the last. Okay. In UV concept, though it is undirected, I am not writing in that way. You can interchange that also. U A to B is this one. Next B to D is 4. Sorry, we have to go for increasing order. That's why it could be C to D. C to D will be 3, and B to D, which will be considered as 4 now. Okay, this is what we can get it. Next, whenever we are running the find set operation, in this case find set operation, whenever you are doing, like, you have to focus on the edges first. Okay, whether the edges are considered for the first time or not, because it is written within the for loop. Again I'm saying with the if condition. Okay, if it if condition, it is asking, like, before that, suppose I'm picking this one, this age. Okay, for this age, find set a will be equivalent to find set b or not. Like, before that, each are individual. Okay, each are individual, so we cannot say both are equivalent. We can go for union. Here in this case we will go for union. If for union, if and only if and only if function and subset could exist, then only we can use union. I must write use union if and only if phi must be present or subset. So here we can say, if we can ask find a or b is equivalent to this or not, we must say no, they are not equivalent, means phi could exist in between them. So we can take the lowest one will be picked first, so that could be written as a with the c, because this one, if we go for checking find set, here we must say no. So that is why with the a, here a is written as a array or a set. Okay, so where we can add a there and c there. If you are confused enough with this one, so I must say it's a P. Okay, because do not confuse, because it's a A by the way. Now it's a P. Okay, now we have to write P, then here P is, they are both individual sets now. For these individual sets, we can add them in A. Okay, whenever we are adding them, we do the operation first. Okay, we are adding it the A, then we are doing the union operation. This is by default union operation. We can perform union operation here. For the first time, once it is done, then we can do the union operation. First of all, we must go for this find set with the union operation. I must write here union. In case of union, once the find will be done, if find set, then union operation. Okay, so the first one we have completed as this. For the next one now, second find set operation, whenever we are doing, we have to check before that within the A, P with C were existing. Now we are coming with PB. Okay, now we are coming with P comma B. Whenever we are doing the find set now, find set with the two different objects, or you can say two different sets. Okay, let us take, this is U for a timing, this is for a timing, it is V. So we know whenever we are finding any common in between, so we can say P is common. So P is a subset. Either it should not be set. If PB will be inside it, so we'll not go for union. Okay, that is why we are finding union, means we are picking that A's or not. We will be doing that, or we will be selecting that A's once it is done. Now we find P which are not equivalent to PC and PB, both are different. For the difference case is C and B, so that's why we can go for doing the union. So before that PC, and here it is a B, so I must write this example. We have taken P2C, which is 1 now as per the color. Next we have taken 2. Next case is we have to go for C with the D. When C with the D, we have to check the find set operation again, whether here in a V, C with D will be there. Here it is U for the timing. Next, whenever we're doing the find set, we must check uh, what's the difference exactly we are getting. We are getting C as a common, which is a subset again. No subset, we can perform the union set. Perform union, then perform union. Perform union set. So once we are doing the performing union set, the answer could be written as P, C, B, and this one is D. You can check that one. I'm just changing the color now. C to D will be considered. Okay. Next will be, next could be B to D. We have to check B to D. A was P, C, B, and D, and V will be B, D, because we are doing the find set. Okay, in this case, so let us assume this is U for us. Here, whenever we are doing find set operation, so we got B, D are common, which is a set again. Though it is a means set means from a V directly we can say either V or U. Okay, if any of this as a part of the common, we must avoid union operation. Okay, union operation will be avoided. Why? Because it is within the if condition. Okay, so here it was, if it is not equal to, then we will go for not equal to means this one which we got, not equal to condition. Okay, this is not equal to condition, like we will get either 5 or subset, then we'll perform it, otherwise we will not perform it. So here we can say the number of times operations with the number of times as per the example. Operations and number of times. First is make set operation. Next one is find operation, find set operation. Third one is union operation, union operation. Okay. So make set, always remember the tips and tricks are, the make set will run for the number of times the vertices are there. Okay, as for the V. So here, as for the example, we are having V. V as 4. So here we can say it is 4. Okay, based on the vertices, we will be writing the answers. So I must write it as V. Next is find set. Find set will have the number of edges because it is basing on the edges. So it is based on the edges. So that's why we, what we have to do, the number of edges are 4. So 4 times it is running, like based on the increasing order, like what was the order that we fixed, it is the number of times are 4. Now union operation is based on the, if a cycle is there, so we have to avoid it. To avoid it, union operation is running. That's why we are not picking this edge, because if we'll pick this edge, so cycle could be existing. In Kruskal we said it's a tree, it's not a graph. Okay, and we are finding the minimum one, minimum weight considered to cover all the edges, to cover all the vertices. Like we have to reach from any of the directions, but the weight should be minimum. That is what we are trying to find out. Okay, so that is why union operation is running for 3 times. Why? Because in if condition we found no need to go for union operation, the fourth case. That is why we set here as this is our third case, this is our fourth case. In fourth case, we are not running it. That is why we said union operation is running for 3 times. In this way, we have found out a result based on the algorithm as well as the theme of it. And I hope it is understood by you. Thank you for watching. Have a good day.